Hello, ladies and gentlemen. Today we are going to start new topic. Before that, we have a do not question. Simplify the expression. To be able to simplify this expression, you need to factorize each quadratic equation. X squared minus 10x plus 25 can be written x minus 5 times x minus 5 over x squared minus 10x plus 24 can be factorized x minus 6 times x minus 4 times inside of the parentheses x squared minus 2x minus 8 can be factorized negative 4 plus 2 x minus 4 times x plus 2 over this is going to be negative 5 and negative 1 x minus 5 times x minus 1 times keep change flip. You need to flip this fraction x minus 1 over x minus 5. If we simplify the like factor, if we simplify the same factor, for example x minus 1 will be cancelled out. From here x minus 5 will be cancelled out, x minus 5 will be cancelled out, x minus 4 will be cancelled. What is left in numerator? X plus 2 over what is left in denominator? X minus 6. So this is your simplest form of this rational expression. Today we are going to learn trigonometric identities. This topic is one of the most important topics in trigonometry, ladies and gentlemen. So there are some identities you need to know that. First, quotient identity. We know that tangent x is going to be written sine x over cosine x. Pythagorean theorem. By using the unit circle, we can prove sine square x plus cosine square x is equal to 1. Another identity is cofunction identities. This is important, ladies and gentlemen. Whenever you subtract any angle from pi over 2 or adding pi over 2, trigonometric function is changing its name. This is important. Sine function is going to become cosine, cosine function is going to become sine, and tangent function is going to become cotangent function. You will also see that if we add or subtract any angle from 270, which means that 3 pi over 2, the trigonometric functions are changing their names as well. What does that mean? For example, there are two key factors here you need to figure out. When the trigonometric function is changing name, you need to determine its sign as well. How? For example, we know that because you subtract angle x from pi over 2, sine function is going to become cosine function. But how am I going to determine the sign of the cosine? How? You need to check the original function. Where is this angle located? In the first quadrant, because pi over 2 minus x is going to be located in the first quadrant. In the first quadrant, what is the sign of sine function? Which is positive. That's why you will say positive cosine x. Look at the second one. You are subtracting x, this is an angle, from the pi over 2. We know that because you are subtracting measure any angle from the pi over 2, trigonometric function is going to change the name. Cosine is going to become sine function. How am I going to understand the sign of the sine function? Check the original function. This angle is located in the first quadrant. In the first quadrant, what is the sign of cosine function? Which is positive. That's why the answer is positive sine x. Alright, let's see different example. What about sine 3 pi over 2 minus plus x? As I told you, if we add or subtract any measure of angle to both 90 or 270, trigonometric functions are going to change their names. We know that sine is going to become cosine x. Okay, how am I going to determine this sine of cosine function? To be able to determine the sine, you need to check the original function. This angle is located in which quadrant? In fourth quadrant. In the fourth quadrant, what is the sine of sine function? Which is negative. So the answer is going to be negative cosine x. Another example. Cosine 3 pi over 2 plus x. Because you are adding any measure of angle to the 3 pi over 2, the cosine function is going to change its name, which is going to become sine x. But how am I going to determine its sine? Now, ladies and gentlemen, check this angle. This angle is located in which quadrant? In the fourth quadrant. In the fourth quadrant, what is the sine of cosine function? Which is positive. That's the reason cosine 3 pi over 2 plus x is going to become positive sine x. Next one is odd even identities. Remember that in the previous topics, if you have a f of x function which is equal to f of negative x, this is even function. We call this is even function. If negative f of x is equal to f of negative x, then this is called odd function. Sine function is called odd function. Cosine function is called even function. And there's one more, tangent is also odd function as well. Tangent of negative x is always equal to negative tangent x. What does the relationship between the sine negative theta and negative sine theta indicate about the function f of x is sine x? Ladies and gentlemen, to be able to prove this, the best method is unit circle. Let's graph a unit circle. When you have a unit circle with the angle theta, let's say that this is theta, this is negative theta. This is reference angle. We know that this point is A plus B. This is the ordered pair. And this is going to become what? A minus B. Why did I say that minus B? Because we know that y value is negative in the fourth quadrant. Look at this. Sine negative theta. What's going to happen? Sine negative theta is going to become negative B. Alright, what is this sine theta? Sine theta is going to be positive B. So what is the relationship between that? Is sine negative theta is going to become minus sine theta. So, which means that if we say that f of x is sine x, f of theta is going to become sine theta. Right? So, if this is negative f of theta is going to become what? If we substitute f of negative theta, then you will get sine negative theta, right? So that this is going to become f of negative theta. So this is proof of odd function. Next. How are the cosine theta plus pi and cosine 2 pi minus theta related to cosine theta? To be able to prove this, ladies and gentlemen, the best method is making unit circle. In the unit circle, this can be written cosine pi plus theta, which is going to be located. This angle is going to be located in the third quadrant. This is the reference angle, which is theta, and this point is going to be A minus B. Why it is minus a and minus b? Because we know that both x and y coordinates in the third quadrant will be negative. So this is going to become minus a, because cosine function represents x value. What about the cosine 2 pi minus theta? Cosine 2 pi minus theta is going to be located in the fourth quadrant. This is negative theta. And this is, what is the x value? Is a, which is positive. What is the y value? Is negative b. So cosine 2 pi minus theta is going to located in the fourth quadrant, and this is going to become a. Now we are going to find this relation with cosine theta. So let's say that cosine theta is here. And what is the point? What is the sign of the point of first quadrant? They located in the first quadrant, positive a and positive b, right? So, and what is the cosine theta? Is positive a. So cosine pi plus theta is going to be minus cosine theta. Cosine 2 pi minus theta is going to become cosine theta. These are the relationship between those angles. Next, what is the equivalent form of tangent of minus x times cosine x? Ladies and gentlemen, tangent minus x times cosine x, right? We need to simplify this. Before that, I would like to remind you some identities. What is that? Sine minus x is going to become minus sine x, right? Next, cosine minus x is going to become cosine x. Nothing is going to change. What about the tangent one? Tangent minus x is going to become minus tangent x. Don't forget this. So, and also there's one more. This is going to be quotient identity. Tangent x can be written as a sine x over cosine x, right? So we are going to use these two identities. Now, I know that tangent minus x can be written minus tangent x because of this identity times cosine x. Can I write this negative tangent x? Can I write this as a negative times sine x over cosine x? I can. Now, can I simplify cosine x and with this cosine x? Yes, you can. Now, negative times sine x is going to be the answer of, or the equivalent form of this expression. Next question. What is the simplified version of 1 minus sine x cosine x minus pi over 2? We are going to find a simplified version of this expression. First of all, ladies and gentlemen, I would like to remind you some identities. The first identity is this. Cosine square x plus sine square x is equal to 1. This is Pythagorean identity. Next is this. Cosine negative x is equal to cosine x, right? Nothing is going to change. Next, cosine pi over 2 minus x is going to become what? Positive sine x. We are going to use those identities. Let's do it. Use it. Into the 1, can I write cosine square x plus sine square x? Can I write it down? Into the 1. Minus sine times sine x times into the cosine x minus pi over 2. Can I write cosine minus pi over 2 minus x. Remember that cosine minus x is also equal to cosine x, which means that this negative is not going to change anything. So let me rewrite this expression. Cosine square x plus sine square x minus sine x times, as I told you, this negative is not going to change anything. So because cosine is even function, cosine pi over 2 minus x. Now look at this. Because you are subtracting an angle from the pi over 2, this is going to change the name. Let's use it. Cosine square x plus sine square x minus sine x times, what's going to happen? Cosine function is going to become sine function, right? Sine x. And this is the angle located in the first quadrant. In the first quadrant, the sign of the cosine is positive. So this is positive sine x. So sine x times sine x is going to become cosine square x plus sine square x minus sine square x. So sine square x minus sine square x will be cancelled out. The answer is, the simplified form is cosine square x. This is your answer. So 1 minus sine x times cosine x minus pi over 2 is equal to cosine square x. What is a simplified form of each expression? To be able to solve this question, we need to know some identities. As you know that tangent is also odd function, which means that tangent minus x is going to become minus tangent x. This is the first one. Second one is, we know that tangent x can be written as a sine x over cosine x. This is quotient rule. Quotient identities. We know we need to use these two identities. First, can I write the tangent x minus pi over 2 as a tangent minus pi over 2 minus x? Can I do this? Yes, I can. Next, because of this is odd function identity, this is going to become tangent pi over 2 minus x. Then, can I write tangent as a quotient of sine pi over 2 minus x over cosine pi over 2 minus x? Can I do this? Of course I can. And remember that, ladies and gentlemen, if you subtract any measure of angle from pi over 2, the function is going to change. The trigonometric function is going to change its name. Sine is going to become cosine x. And we know that this angle is located in the first quadrant. In the first quadrant, the sign of the sine function is positive. So that's why cosine x over, what about this? Because we are subtracting x from the pi over 2, this cosine is going to change its name. It's going to become sine function. And this angle is located in the first quadrant. That's why the sign of the cosine function in the first quadrant is positive. So this is going to be positive sine x. After that, what is the cosine x over sine x? Is cotangent. So the answer is going to be negative cotangent x. So this is your answer. Next one. Before solving this question, I'm going to remind you some identities. The first identity is this. We know that sine minus x is minus sine x because this is odd function. Same thing, tangent minus x is going to be minus tangent x. And tangent x can be written as a sine x over cosine x. These are enough. These are the three identities we are going to use to be able to simplify this expression. So we know that sine minus x can be written minus sine x times tangent minus x can be written minus tangent x plus cosine x. After that, ladies and gentlemen, we know that negative times negative is going to be positive sine x times tangent x can be written sine x over cosine x plus cosine x. If you multiply this, you will get sine square x over cosine x plus cosine x. What is the denominator of the cosine x? Is 1. To be able to add these two fractions, we need to expand this by cosine x. Then you will get sine square x plus cosine square x under the same denominator, cosine x. Do we know that from the Pythagorean identity, cosine square x, sine plus sine square x is going to become 1 over cosine x. You can leave it as a 1 over cosine x, or we know that 1 over cosine x is secant x. These are correct answers.